Good morning, good evening, or good afternoon, depending on where you are. Um, Actually, I'm in San Francisco right now on a business trip. So it means it's 2 a.m. in the morning right now. I woke up 10 minutes ago. So let me be straightforward, completely honest. Let me put it that way. If I fall asleep during this presentation, it's because I woke up 10 minutes ago. I'm just sipping hotel's coffee, to be fair. It sucks. And I will answer all the questions on Slack probably first thing in the morning, all right? Which means in my case, like in a couple of hours. All right, so I'll just set my timer so that I see how much time I have left. And let's get it started. Clean code. What does it really mean? Well, it's front and center in the title of this talk, so probably I should say something about it, right? To be fair, I'm not good at definitions, so instead I'm going to share a quick story with you. In one of the organizations I have seen, people were trying to have a consensus on what is clean code, on what clean code is, and the rules were forced into the code base as well. Don't get me wrong, whys and decent advices, things like, well, clean code means testability, clean code means proper naming, clean code means having not more than X dependencies in a class, and so forth and so on, right? But at some point, the team has noticed that it was actually slowing them down, to be fair, without improving the quality of the business features that much. So the advices, they were also kind of declarative, I would like to say, because after all, what does it really mean that the code is testable? What does it really mean that I can't have like 6 or 7 dependencies in a class? What if I really need that to deliver a feature and I don't know how to get rid of like 5 dependencies? I don't know how to refactor. So what I think nowadays about clean code is this. It might be a little bit controversial, but I think it's not fundamental. I think it's emergent from having good architecture, clean architecture. I think it's emergent from having good modularity. I think it's emergent from having clean model. I think it's like when you have clean model, when you have clean architecture, then you have this feeling of, oh, the new code I have to write, I have to implement, it's effortless and clean to implement. That way around. So I think clean model, clean architecture, these are fundamental principles, and clean code is like first level derivative of that, like thing which is emergent. That's why this talk could have been easily called eternal practices of good architecture / model. And to be fair, we are going to focus on these, on good architecture and good model, but however, I will write a lot of code today, and I want to warn you, because the code that I'm going to implement today won't be perfect, and that's on purpose. In fact, part of the code I'm going to implement today is going to be shitty on purpose. I want us to see, I want us to implement something which doesn't look perfect. I want us to see the space for improvement. I want us to see problems, and I want us to discuss the possible solutions, all right? So let's start with the first example. I've been recently keen on those e-scooters. That's why I picked that as the example for our first case, for our first domain, e-scooters. For the first like 10-15 minutes right now, I'm going to implement stories naively, all right? I cannot stress that more enough. Naively, I'm going to implement stories. So probably during this live coding session, you are going to think, hey, we could have done this in a different way. That's okay. We are going to discuss that later on. So we have some user stories. Okay, they are also naive. Riders, they can place reservations, right? Reservation contains a particular e-scooter's ID, rider's ID, and it's valid for a specific amount of time. Also, the new reservations, they are active by default. So probably I know I need some sort of a status. They can also expire or be canceled. All right, so let me do this. I have a class called reservation. I will fill it with some data. Like I have status, I have rider ID, e-scooter ID in the sense of those nice value objects, right? I have valid till date. I have the status, I have constructor, and so on and so forth. Maybe I even have some behavior so that my entity is not that anemic. I can expire, I can cancel, and that's it. But of course, we have more stories to implement. Next thing we need to do is this. There can only be one reservation for a particular e-scooter at any given point of time. Shocker, right? No one could have predicted that. I can't check it from the level of the reservation, so probably I need some sort of a service. I need a repository for reservations. Let me do that. I have reservation repo in the sense of a hash map. I think it's enough for our presentation. Also, I will have a service right now. I will call it, let's call it e-scooter service. And our e-scooter service will inject the repo, and we'll have one public method called reserve. All right. When I want to reserve, as it was said in the last user story, I need to check if the e-scooters might be reserved by someone else. So I have this constraint. I have this invariant that I need to implement. We'll do that in a moment. If it's not reserved by someone else, we can return true. I know React result class would have been way much better, but again, let's ignore this for the sake of this presentation. I can save a new reservation when the e-scooter is not reserved by anyone else. Let me create a new reservation with rider ID, scooter ID. Let's say it's by default for 10 next minutes. All right. Okay, we are left. We have to do this. What does it mean it's not reserved by anyone else? It means I have to go to the database, right? See if there is any reservation. If there is a reservation, I need to check if it's not my reservation, and maybe if it didn't expire. I can do it like this. Let's go to the repo. I can check if there is a reservation, if it's not owned by me, and if it's still active. That means I have to go back to my reservation class and create new methods. All right, so far so good. That's easy. I can ask the reservation, hey, are you still active? Are you owned by this rider ID? Nice. I have repo, I have e-service, e-scooter service, I have reservation entity. I can even probably introduce some tests, right? Let me do so. I will have probably like 2 tests is enough. I know we have more scenarios to cover, but let's cover just 2 tests. Can reserve available scooter and can't reserve already taken scooter. I have the reservation repo, I have e-scooter service, I have some sort of constants. I can do this right now. E-scooter service, please reserve this scooter. I'm this rider. It returns some result, and I need to check if the result is true, right? I can also check if in the repository, I know checking through service would have been way much better. If in the repository, I can see reservation for this scooter and if it's owned by this rider ID. All right, so far so good. Let me run this test and see if it's green. It is green, cool. I can now copy paste this and use it in the second scenario, which is, I guess, a little bit more complex because I need in the given section to place a reservation by rider number 2. That means that rider number 1 actually can have it. So I can simplify this, I guess. That should be false, right? And also in the repo, I should still be able to see reservation placed by the first rider, second rider, sorry, first in the test. All right, so far so good. Let me go back to user stories. I know that design has some flaws. It's there is space for improvement already, but you know we don't have time. We have much more stories to cover from our product owner. So the next story goes like this. Sometimes we have to maintain the e-scooters. Like for instance, there is we need to replace the battery. All right. To do that, we put scooters into this special maintenance mode. When they are in this mode, they can't be reserved, which makes sense, doesn't it? Also, the other way around, scooters which are currently reserved can't be put into the maintenance mode. So when I'm reserving, I need to check, hey, maybe you are in the maintenance mode, and vice versa. If I want to put scooter into this mode, I need to check if maybe it's currently reserved. All right, so let me go back to our code. Probably finally, I need some sort of a e-scooter entity, which will have ID and the Boolean flag saying if it's in this maintenance mode. I know, again, Boolean, we can do it better, but so far so good. Let's leave it like this. I need repo for e-scooters. I have it in here again, hash map. I can save, I can find by scooter ID. And now I am able to deliver the method called put scooter into maintenance mode. Let me do it in the e-scooter service, maintenance mode. So to do that, I will have to check if it's reserved. If it's not reserved, I will be able to go to the repo, put into maintenance mode, and save back the entity of e-scooter. All right, so let me inject e-scooter repo here. All right, so far so good. Done. That means now I am able to implement the invariant. Hey, I can do it if the scooter is not reserved. So if it's reserved, which scooter? That scooter when? Now. Then sorry, I can't do it. And by the same token, I have to go to the reservation and ask the question, maybe is in maintenance right now, which means I can't do it. So I have those two new invariants, those two new conditions to implement. Let me do that. Is in maintenance mode, we go to database, we check if it's in the maintenance mode by this ID. If it's reserved, I go to the database of reservations. I check if it's there and if it's still active. All right, again, so far so good. Let's see what happens to the tests. I suspect they will be failing, right? Because first and foremost, we need to inject a new dependency here, right? Let me do so. E-scooter repo. And also, I think, even though now everything compiles, I think that will be red. Yes, why? Because when I want to put scooter in the, and when I want to ask if the e-scooter is in the maintenance mode, in here, there is no e-scooter record in the database. So in all of the tests in the given section, probably I should introduce something like this. There is e-scooter in our repo. I can do it like this. So remember, like this is just an example. So I have two tests. In a real life projects, I would have like probably 20. So in all of them, I will have to add this given section. Let me do it. There is e-scooter. All right. So far, so good. There is scooter here, and there is scooter here. Let me run the test right now. And if they are green, we will be able to introduce a next test. Next scenario says something like this. I can't reserve when scooter is in this maintenance mode. So now in the given section, I have to put scooter into the maintenance mode so that later on, when someone tries to reserve it, that should say false, and I shouldn't see any reservation placed on this scooter. All right, so there is scooter in maintenance mode. Let me run all of the tests, see what's going on. It's green, cool. All right, I know, again, space for improvement, many things that we could have done better, but we don't have time. There are more stories to implement. Next story, the last story, I promise, goes like this. Sometimes we predict this so-called high demand for e-scooters in particular zones, in particular areas. So it gets worse, because so far when I was placing a reservation, I needed to check if it's in maintenance mode and the other way around as well. But now I get this new concept. After big events, maybe new stadiums, after a game or a concert, we want to be sure there are e-scooters ready to ride, ready to use. So we deliver them there, and they can't be reserved or put into the maintenance mode until the event finishes and people started to leave. We want them to see the scooters, right? So also, we can't use scooters for this demand forecasting if currently they are reserved or in the maintenance mode. So I have a new invariant to check. Let me do it quickly. I guess we can introduce this demand entity. Demand is very simple. I have demand for a scooter ID until a specific moment in the future, right? I can also have demand service and demand repo. Again, demand repo is demand service is very simple. I can add a demand. I can ask if there is demand for the scooter. And now we can go back to our scooter service and implement that. So here I can inject demand service, right? Oops. Demand service, which means I will have to go to the test as well because we have new dependencies, but I know how to do it. Here, oops, demand service. I can introduce new dependencies here. And now I am able to check if in the e-scooter service, there is a possibility to add the demand. But to do this, I need to check if the scooter is in the reservation. So if it's reserved right now by anyone else, and also if it's being maintained, maybe. So I need to copy paste again those invariants that we have from the previous example. Let me do it. Here. Right, so far so good. Also, now if I want to reserve, I need to check if there is demand for this e-scooter. Oof, that's very tedious to do, but I think that's our last story. The same invariant needs to be copied to when I want to put things into the maintenance mode. So let me double check. When I try to put into the maintenance mode, I check reservations and demand. When I want to reserve, I check if there's any other reservation, if it's there, if it's maybe in the maintenance mode, if there is demand. And if I want to add demand, I need to check maintenance and reservations. Oof, I think we are good. But the last thing we need to do is to add these conditions about demands here. All right. So far, so good. Last thing we need to do is correct this. Like that. And here we can just add now. I know clock would have been way much better in here to introduce. Last thing to do, introduce a new test for demanding. Very simple test. Can't reserve when there is a demand. So if there is a scooter, and the scooter is also used for this demanding forecast, that means I can't get it, right? Let me run all of the tests and see if they are green. I know there are more scenarios to cover. The tests are green. Let's stop for a while. So what's happening right now? That's a pseudo architectural diagram, okay? E-scooter service needs to coordinate 3 places in order to answer the question, can I get the scooter? Also, when I was adding the new concepts like demands and maintenance, I needed to modify existing code. When we needed to add code related to demands, I also needed to modify code related to reservations and code related to maintenance. They shouldn't have anything to do with demands, right? Or maybe shall they? I don't know. Let's see. I have bigger problems than this. I also have problems. I have technical problems because currently I need to coordinate 3 places in the database, right? So I get the answer or the answers from 3 places. Hey, is there any other reservation? Hey, maybe scooter is in the maintenance mode. Hey, is there any demand requested for this e-scooter? And by the time I got the answer from the 3rd place, maybe the 1st place, the reservation has changed its mind. Oh, I know how to do it. I know how to overcome that problem. I will just say, hey, you know what? Is there any other reservation? No, don't do anything until I go back to you. The same with e-scooters, the same with demands. I will essentially block everything that I need to block. But now, if there is someone, and then I will block, if there is someone who wants to at least just change the description of the demand, let's say, a use case which is completely unrelated to whatever we are trying to reserve, those use cases will be blocked in here, right? So now my design is blocking unrelated business use cases, right? And let me stop for a while. If I introduce if I got rid of booleans, if I introduce optionals, if I shorten the methods in my code, would it help? I don't think so, because it's not the problem with the code. The problem is with the design. And probably you have spotted that just with the first example, when we only had the reservation, because first we were asking, is there any other different reservation for this scooter? And then if not, we were saving new reservation. In the meantime, someone could have inserted a new reservation in our database, which means our system would have been inconsistent, right? But again, I know how to overcome that naively. I could just block the entire table of reservations, right? But that would mean my scalability would be very poor. So it's either poor scalability or inconsistency in my system, right? Also, I had poor testability. Why? Because I needed to add multiple dependencies to my test every time we were introducing new features. I needed to add multiple lines in the given section of every test as well when we were introducing new features. Also, we had problems with cognitive load. What is that? So, in a nutshell, when we learn new information, the brain classifies and stores this information in so-called schemas. There are like folders in our neurons, in our memory, when we store similar information. And cognitive load theory talks about the premise that we have the working memory, which has a limited capacity. And when we overload this capacity, we reduce our effectiveness. So in other words, the simpler the schema, the more effective we are. And our schema for blocking e-scooters is quite complex. We need to remember about reservations, maintenance mode, and the demand for a class when I want to block something. And it gets worse because if I get a new feature, just display on a map, ready to ride scooters. What does it mean ready to ride, by the way? It means not reserved, it means not used for demand forecasting, and it means not currently maintained. So again, if I want to implement this feature, I'm not going to do that properly, but just pseudocode, I would need something like this, probably like scooters view. Oops, scooters view. In here, I would like a DTO. I would need like a map service. And map service, again, needs to talk to the same three places that we used to talk when we were reserving scooters, right? A map service would have a method like this. Give me all scooters in this area, which means I need to go to, hey, to the scooter repo or scooter module, whatever it is, find by position, not in maintenance. I need to filter out those which are used for demand and filter out those which are already reserved, like this. It means I need new API in here. Let's imagine that's a new module, reservation, not new module, but that's a module, not a repository. I need a new API here and I need a new API in here. And then I need to coordinate this just to get the answer, hey, which scooters are ready to use? Let me get rid of that. What does it mean? If I need two new places where I need to introduce new APIs, probably I have problematic team dependencies because of course I will have three teams. One team will be responsible for reservation, the other team will be responsible for maintenance, the other one for demands. But wait a minute. If I need to coordinate three teams to deliver such a simple feature, I guess the dependencies between teams are going to effectively slow us down. That's a heuristic I sometimes use. How many teams get a task to their backlog to deliver that story that we are about to deliver? If many teams, probably cleaning the code won't help us. Probably cleaning the model or cleaning the architecture and how the teams are aligned around the concepts in our domain would help. Currently, our map service needs to talk to three different places, just like e-scooter service had to do. The same three different places, and it gets worse because we are going to talk to those three places over and over again. That's essentially violating don't repeat yourself principle. And I don't care about code duplication, to be fair. Maybe I'm controversial, but I don't think there is anything wrong with code duplication. I think code duplication is not a problem because maybe the code which is duplicated will evolve differently. I don't have such information right now, so I don't want to create artificial abstractions. Duplicated logic is problematic because most likely in the code base, it will look differently code-wise, right? The same logic implemented differently. I had the same logic in e-scooter service. I was talking to the three different places, which I had with map service. I also have coupling, but not only the structural coupling of several classes being dependent on different classes and difficulties with refactoring. That's bad, but it gets worse. I will have logical coupling. And what's that? Logical coupling means that I will have places in the code base that need to be changed together, even though they are not connected in the code base. So it's worse kind of coupling. If we add a new concept next to the maintenance, reservations, and demands, I will have to change e-scooter service, map service in all of the future places as well. All right, enough of problems. Let's talk about solutions. Why is it so? What to do? So the trick in those situations, because I see them over and over again, is to spot the fact that those three concepts, reservations, maintenance, and demand forecasting, they actually affect one behavior that was missed, and there was no notion about this behavior in any of the user stories. They all affect one question: is the scooter available? So probably I should be talking about availability model instead of talking about maintenance, demands, and so on and so forth. There is no notion if the in the user story, in any of the user stories, about availability, but yet I need one place to answer this question instead of gathering the answer from 3 different places or 4 different places in the future. That's the observable behavior I want to talk about from the point of view of e-scooter service or map service. And all of the things we have just implemented might have been just implementation detail. I would like coupling to observable behaviors, not coupling to implementation details. In other words, a design effect, sometimes called a content coupling. It's like asking a driver to understand how the rack, how the pinion, how the joint system, how they work, when all they want to do is just to turn the car using a steering wheel, right? In other words, we are violating information handling principle. All right, but these are just words. Let's talk about code base. Let's talk about how we are going to fix that. So one way of fixing that would be actually spotting the fact that probably we need one place to answer the question, hey, is the scooter available? So let me do that. I will introduce availability model. Let's rename e-scooter to e-scooter availability, and I will copy paste availability because I sense that it will be used in the future. Same here, that's not e-scooter repo, but e-scooter availability repository. And last but not least, let's go to our famous service, which is already very big, but we'll refactor that, don't worry. And let's call it e-scooter availability service. All right, like this, cool. So the trick is that to understand that from the point of this availability model, which there was no notion about in the user story, I cannot stress that enough, we shouldn't be talking about reservations, about demands. I don't care. I just need to answer the question if it's available or not. Same applies to our entity. Let's go to our entity. I don't want anything about maintenance here. I just want to know if it's taken. And if it's taken, then till when? Or I can just introduce this field in here. If it's taken, then till when? Well, probably if I introduce new availability by our constructor, default constructor, maybe taken till will be null, which means the scooter is available. All right, let me get rid of this. Again, maintenance, not the language that I want to see in availability. I don't want this cognitive load. What I want to talk about here is the language of availability. So I guess I need 3 methods. I want to release, I want to take, I want to answer the question if the scooter is available. Let's make it package private. What does it mean it's available? It means that taken till is now, or maybe taken till is after the time we are, sorry, is before the time we are asking, right? So far, so good. What it means right now is that I am able to implement release and take functionalities, which are very simple. If it's available, I can take it and I can specify till when. And if I'm releasing, it's always very simple. I just need to mark taken till as null, and we are good. So now we have entity which is responsible for making e-scooter available or not. But that's not the only thing we need to do. The code doesn't compile. Let me go back to the service. From the point of view of the service, I don't care about reservations. That's not the language I want to see here. I don't want to overload the reader of this class, right? The service of availability should deal with availability, right? So let me fix this. Add constructor parameter like this. Cool. I don't want demands in here. I know this logic should go somewhere and will go somewhere in the future very soon. I don't want reservations. I don't care about reservations. I don't care about demand language. I don't care about maintenance. To be fair, I don't care about anything. What I care about is how to release and take the scooter. So I care about this. That's the only thing I care about. I want to take the scooter, maybe release, but let's ignore releasing because it would look almost the same like taking, but we would be calling different method. And now I want somehow the logic of the maintaining, of demand forecasting, of reservations somewhere in the upper layer. Let's do it. Let's create reservation service. Reservation service will have to adjust to the language of availability. Again, no notion of availability in the user story, but hey, that's life, right? The benefit of thinking in that way is that now, from the point of view of reserving, I don't care why it's not available. I just need to ask if it's available so that I can store my new reservation and take the scooter. But I don't need to know from the point of view of reservations, hey, if it's maintained, if it's under specific demand. I don't care, to be fair. What I care about is this. I want to take the scooter, maybe by default for 10 minutes, and I'm doing this now. And if that's possible, please do it. And I will do my job. Maybe I'll just store a new node of reserving. And otherwise, I will just return false. Again, I know result class would have been better. So that's the only thing I need to do from the reservation class. Notice how simpler it became. I don't need to add any new if condition when there is new reason to block the scooter. Same applies to maintenance service. It now looks like this. Again, adjusts to the language of availability. And same applies to demand service, which is already somewhere in here, but we need to refactor that to the new version. It's almost the same. When I want to add demand, I need to ask, hey, can I add the demand? Yes, you can add the demand because we can take the scooter. So I'm doing my job for my reasons of demand forecasting, and no one else cares about it. All right. Probably we'll have some problems in the test. Of course, we have problems in the test. Let me get rid of this because we need new dependencies here. I have dependency related to availability, demands, reservations, and maintenance. And if we take a look at the test, they are all speaking with language of reservations. So probably the test should be using reservation service, not e-scooter service. Now I can refactor to this. All right. When I want to add demand, I go for the demand service. When I want to add maintenance, I go for the maintenance service. So everything has its own place right now. If I run the test right now, hopefully they will be green. Let's see. Oh, they are green. Cool. But again, I know too many things from the point of view of this test. So probably if I go to the scenarios, again, tests are related to reservations. If you can take a closer look. Do I care from the point of view of reserving a scooter if it's reserved because there is maintenance? I don't care. I don't care if there's demand. I just need to know if it's available or not. So I don't have that many cases. That way of thinking actually increases the testability of our classes because I will have less conditions, less edge cases to check. Actually, I have just two things to check. Can reserve available scooter and can't reserve scooter which is already taken, which is not available. What was the reason to take it? I don't care. I don't really care, to be fair. So I can refactor those two scenarios to our new set of scenarios, which I can copy paste because I'm running out of time. So I have scooter which is unavailable. I put it into unavailable mode, scooter which is available, and two cases which we just described. Which means from the point of view of this test, I don't care about demanding and maintaining, and my testability is so much better right now. All right. Of course, I might have like a test in a higher level, like integration level, where I could check, well, hey, if I'm using a scooter to this demand forecasting, I can't maintain, I can do that, right? But from the point of view of this service, which should have been called right now reservation service test, to be fair, I don't care about demanding and maintenance. Also, I shouldn't be aware of the fact how to construct the e-scooter service because this is implementation detail. So maybe if I operate on the contract of e-scooter availability service, I can use some sort of a stub like this, right? That's another way of doing that, probably preferable way of doing that. All right, let me do it, which means now we have to correct this, but that's going to be easy. I just need to teach my stub to return false if we want unavailable scooter. And here I need to return true. All right, so far so good. If the tests are green, we can go back to slides. Let's see if they are green. But notice how simpler the code became. The reservation code just needs to adjust to availability. Same applies to maintenance, same applies to demands, and then they don't know about each other. How to notice that in our project? So when I see requirements, naive user stories like this, reservation completed, demand requested, I ask a question, so what? What does it really change? What's the outcome? The only outcome is that the status in the database has changed, or there is a reservation record? I doubt it. If that's the only outcome, probably you are dealing with create, read, update, delete applications. But probably there's something more. I need to notice the fact that eScooter became unavailable. Okay, so all of those three things are just ways of making Scooter unavailable. I have to dig in the user story to find it out. Maybe I have just one example. So in this case, I can ask a different question. What else can have the same result, dear business? What else? Do you predict something? I can anticipate. Do you predict something like like maintenance mode in the future? Like I can ask those questions, but be careful because someone may say, don't complicate. The problem is really complex enough. We don't want much time. We don't have much time. So please don't complicate. And I heard that many times when I ask those kind of questions, but it's not complication. It looks like complication, but it's not, to be fair. It's like in chess. Imagine we don't know the rules of chess, okay? And we are about to understand them by asking questions so that we are able to implement the game. Hey, can bishop move there? How about there? Can it be there? What about white bishop? Does it differ? Only to understand that instead of like multiple if statements for each field, we got to understand the general rule. Bishops, they move diagonally. So this is like fake. This is alleged complication. And this fake complication leads to proper abstractions, to be fair. Thanks to this, I was able to understand, hey, I'm missing availability model. There was no notion about this in the user story. But what if the answer is like this? It's not only implementation detail. In the maintenance, in the demand forecasting, we have rich model with dashboards. It's very, very, very big. So I can't just use it inside of the availability model. All right, that's fair. That's fine. There is a place for everything, and everything is in its place. I think that's Benjamin Franklin who said that. The same applies to our code base, to our architecture. I need to understand the relations between modules in this case. They all affect availability, but the availability does not care about them. And also they don't care about each other. As a developer, I rarely have to talk or understand all of the upper modules. I just need to answer the question, is the scooter available? I also need to understand upstream versus downstream. In other words, who adjusts to whom? In this example, the availability module does not care and know about language of maintaining, reservations and demands and riders because it reduces its cognitive load. The module just published a language. Hey, take it or release it. I don't care why. Other way to find it is like this. Ask the question if there is a single source of truth for every commonly asked question in the user story. First commonly asked question might have been like, is it available? Second might have been, where is that? And I want one place in the code base to answer each of the questions, right? And I want one model to answer each of the questions so that the model is cohesive. And I'm not talking just about logical cohesion. Logical cohesion would be grouping e-scooters all together because they are somehow logically logically related. But in fact, I want two different models with two different set of data and with two different set of behaviors. That's actually a great way to explain what cohesion is to a junior developer. If I take a look at the e-scooter availability, if I ignore ID, which is only there to map it in the database, I have taken till field, which is used by every method in our class, right? Which means cohesion is high. If I introduce like a new thing here, maybe register position, it's a new field that's not going to be used by anyone else. So the cohesion would be smaller. I want my code to be cohesive so that, again, the cognitive load decreases. And there is a fence between them. Of course, they can integrate with each other. The question is how they integrate with each other. The question is, do I share language about demands? Do I share language about reservation? Do I share language about maintenance? No, I want one integration event. I don't care about the reason. Scooter taken or released. Of course, I can say like more specific events for the sake of auditing, but these are private events. We need to understand published versus public. Published is even worse than public, because I can have a private class, but yet somehow I serialize using JSON, of course, my internal details to someone else. And even though the class is private, the internal information was sent somewhere else and became published. So my advice is always be liberal inside of the model about the code, strict on the outside, who we talk to and how we integrate. I want to focus on one word from the first user story: reservation. What is a reservation right now? If we take a closer look, that's just the effect of the decision being done in the availability model, right? There was no notion about availability model in the user story, but there were many things about the reservation, which is only effect of that decision. In domain-driven design terms, maybe decision is the availability is just an aggregate which makes a decision. That's the effect of the decision. So it's just a read model. Even though it was front and center in our user story, we need to find real concepts and real abstractions. And oftentimes, user stories are just full of user interface concepts. But again, hey, user stories are just beginning of the conversation. We also need to understand different types of logic, to be fair, in our user stories, like can't spend more money than you have. That's a logic around consistency. I have building block called aggregate to handle this. I run a command and I check in the database. So by having the command state and the state of the current thing in the database, I can make a decision. After charging a payer, an external system must be informed. That's another logic. Different kind of logic, integration / application / process logic, nothing to do with aggregates. They can be used in this integration logic, but this is coordination. I have application services or sagas for that. ISBN of the book must be correct. Self-validation, different kind of logic, right? Order forms are grouped into packages. I want to concentrate on that. That's a good example. If I see a requirement like this, I ask the question, so what? What has happened? Probably now we can display order forms in a package on one screen. Okay, that means this is just a presentation logic. This is just a read model. Even though we had like 10 user stories about this, this is just presentation logic. And I want to mix that with orders because, again, cognitive load would be higher. Let me skip this. And let's start with our next example. Let's play a game. So we are going to switch domain for the last 10 minutes or so. The game is very simple. Each of the players, and there are 2 players, each of the players get 2 cards. One card says cooperation, the other card says betrayal. And we are playing the cards simultaneously. If both of us play cooperation, it's 3-3. If I'm the sucker who lost, it's 0-5, maybe 5-0, or mutual betrayal is 1-1. All right, I have code which which orchestrates the process. And I have behavioral strategy as a parameter. Strategy is like, I have to stick to a strategy when I play. One of the strategy might be, I always play cooperation. The other one might be, I always play betrayal. The other one might be, I play whatever you played in the last hand, something like that. All right. So let me take a closer look on the code in here. As you can see, it looks like this. I have behavioral strategy, that's interface. I'm going to show the behavior. I can react to your behavior, that's the game. Let me introduce some strategies. That's the result, so the score. I can have mean strategy, which is mean, always returns betrayal. I can have sucker strategy, always cooperates, no matter what. I can have random strategy, which randomly returns something, or maybe something which is more sophisticated. I will call it tit for tat. So it starts with cooperation, and then it just represents whatever you played in the last hand. All right, let's play a game. Maybe, I don't know, new random strategy versus mean. Let's see if it pays off to be mean. It's a draw, 1-1, as you can see. All right, but I want to concentrate on something that I frequently see with many teams that I work with. At some point, we need to also send information about the result via email, maybe save it back to the database, I don't know. But at some point, we need to save information only if the result was like more than 5, If it's Friday, then we are going to save the game. If not, then we are going to save in the middle of the game, things like that. In other words, I will have many if statements in this code in the future. And people say, hey, it's not readable, it's not testable because I will have more dependencies in that service and so on and so forth. People who are like mature with this kind of design, they know, hey, but you shouldn't be mixing the domain logic, so that the essence of the game with the external effects, with the so-called application logic, like saving, loading, sending emails, and so on, with so-called distractors, maybe. I don't want to mix them all together. If I see a long method in my code base, I want them to be separated. And even if I'm not familiar with what's domain logic and what's application logic, even if I want to test that code, I will sense that, hey, maybe sending and saving shouldn't be part of this because I want to test the result and that's it. So the red thing goes to the second, to one method, and the white thing goes to the second method. And now I'm able to test the red thing without having to stop the entire system, right? Which is fine in simple cases, only in simple cases. The real case is like this. You don't know that that's the distractor. You see, take a look at the very long business process, at the very long method, and you want to know how to make it smaller. In this case, I suggest asking something which I call as-if question. As-if question might be something like this. If that was a credit card score application, one of the as-if questions would be, what would have happened if I had applied for this card 10 years ago when I was 20 and I was a student? What would have happened about my credit score? Don't do it right now, but tell me the answer. If that's e-commerce, the question as if might be like, how long would it have taken if I had paid for that 10 days ago on Sunday? How long would it have taken to deliver the commodity? Don't do it. I don't want it, but just tell me give me the answer. As if question. Is there any as if question I want to ask here? Might be. Maybe I don't care about the points. My question would be, what would you have played if I had played Cooperation 3 hands ago? I don't care about the points. So now, thanks to this, I am able to understand that maybe I want the first 5 or 6 lines of this code somewhere in a different place, and the calculation is just an external effect. That would be as if technique. Let me try to do it in the code base and see what kind of troubles we are going to run into. So sending email and saving, we know that's a distractor. We don't care about this. I want this to be separated from the point calculation, right? I want to extract this, but I can't because I need card 1 and card 2 to be passed to calculations. So I need to introduce some sort of a stable behavior. I can call it late behaviors. So which will encapsulate 2 different cards, 2 different behaviors. So in a real project, probably introducing this stable behavior, this stable interface as an outcome of this story would be much more harder, but it's still doable. I can introduce that here. Behaviors, it's just encapsulation of 2 behaviors. And now I am able to pass the behaviors in here instead of passing 2 cards, and pass the plate instance here. All right. What it means is that now I am able to, first and foremost, fix that code. And this is nothing more, nothing less than context mapping from DDD. I have to map the effect of one context to a second context where we talk about points. In the first context, we just talk about behaviors. In the second context, we talk about points. But also, I am able to introduce a new thing in here. Oops. Yeah. Now I am able to introduce new thing in here. And that's a very important moment. How do I call this? It's not a game anymore, right? Because there are no points. Maybe I am just distilling a new concept. I will call it interaction, okay? Interaction between 2 different players. I can even put it in the separate model if a class, let's agree, if it represents a new model. Interaction. Okay, let's do it like this. Interaction between 2 different players. I can get rid of that. Cool. Which means now I am able to build concept of a game using a lower level concept, which I just distilled. It's just interaction plus points calculation, or maybe it's even more complex because a game, it's like 200 interactions plus points calculation. Now, if I have this change to the requirements, I don't need to touch the interaction. I will just touching the game. Let me do it. I play 200 hands, right? Each of the hands is just one interaction. We calculate points and we have to sum it, right? How can I sum it? We start with 0, 0, and then we just add. All right, let's see what's going on with our game, if it's still working. Yeah, so it pays off to be mean, as you can see. 103 to 588. All right, I'm running out of time. I need like 4 minutes more. Maybe if I have new requirement, then the first thing I try to do is to understand how to build these requirements. Let's say the requirement is a tournament in the language that I already have, in the language of concepts that I already have. Maybe a tournament is just everyone plays with everyone else, including themselves, plus results table. All right, I am able to do that. I am able to do that. Let's do that. Let's do it. Let's play tournament. Tournament is like this. I have multiple players. I have a table of results, and every player plays with everyone else. A game, right? So I'm using lower level concept to build yet another level of abstraction, P2. All right, this is a result, right? And I need to merge the result to the results table, and now we are able to play a tournament. Let's introduce some players. We have a random strategy, we have tit for tat. Let's allow suckers to play as well. Why not? Let's allow mean strategies to play as well. And let's play a tournament. All right. Play players. Cool. Let me run this. Who won? Again, it pays off to be mean, as you can see. One last thing I want to talk about is to understand that this is an example of different levels of abstractions. I have a low-level concept, no notion about this concept in the user story. I just had to understand that it's there. I had to distill that. Thanks to this, I was able to build a game. Thanks to this, I was able to build a tournament. It's like with OSEI model, right? It's just like with our availability. I had a layer of capabilities that I exposed and layers of operations that were working thanks to the capabilities we exposed. That's chapter 16 from Domain-Driven Design book. Last thing I want to discuss is this, because I sometimes get this pushback. Wait, but there is no way to practice it. The examples in the web are very simple, and they don't allow to think in that way. They don't allow me to think that way, or they don't allow me to implement code in that way in my project. My answer is always like this. Really? You can't do anything? You can't learn this, right? Take a look at the world that surrounds us. We use Uber, we use e-scooters, we use banking applications, we use tremendous amount of applications right now. Think about how would you model that? Don't code it, of course, but how would you architecturally model that? What kind of models, what kind of bounded contexts are there? Think about it, maybe sketch it, and then come back after 2 weeks and see a new feature and think about it. Hey, does my model defend itself? Can I model the concept that I just see, the new feature, in my current model? I will give you an example with our game. Years ago, I was on a very, very boring vacations. I got tricked, to be fair. I got tricked. I was a very boring vacation. But luckily enough, I had this book where I learned about this prisoner's dilemma. You might be familiar with that game. The game is called Prisoner's Dilemma. Actually, there are books, not only books, there are shelves of books dedicated to that game. Sociologists say that we should be studying this game to understand how to prevent next war. And I understood that game, and I started coding that game because, hey, I love to code. I coded that game, and then I understood that actually not only companies, not only countries play that game, but also humans and other animals. I can model Darwinian evolution with Prisoner's Dilemma, and we are going to do that right now. I will give you an example. If there are two birds, they can't get rid of a bug from the tip of their head themselves. They need a friend to help them. But the friend which got the help might just fly away and say, you know what? I don't want to help you. I don't want to return the favor. They will be mean, right? But guess what? Birds remember who behaved like this mean bird in the past, right? They actually play Prisoner's Dilemma iteratively. So the new feature would be how, in the current model that we have, I can model evolution. Evolution is just, I can say it's a tournament with elimination of the weakest participant. I can play that iteratively until I have one last participant. Let's do it, and that will be the final act. Like this. Evolution. Right? I have I have generations, and if I have more than one generation, I will play evolution one more time. Otherwise, we're just returning null. Sorry, not null, but the winner, right? What does it mean to play one more time? It means, hey, go here and play a tournament, but play only with the players except the weakest player, right? So I prepared that code in here, just sorts the code and skips the weakest participant. So I was able to build evolution using the language we already have as a higher level abstraction. All right, so let's play evolution. But before that, maybe let's introduce a new strategy. That will be the last thing. For the base, we are going to use tit for tat, but let's do something more sophisticated. Like this strategy might, for instance, remember that they have seen betrayal, all right? And then, if that's the case, they will always play betrayal till the rest of the game. Otherwise, they play cooperation. How to call it? So it's good to describe what it does before we start naming. It's something that will remember that like 10 years ago, you have done a mistake. And if you did that, they will remember that and play betrayal till the rest of the day. I don't know how to call it, like something like that. I don't know, good memory. Yeah, that's a good name for that. Let's add this to our game, to our evolution, and see who will win. New good memory in here. And instead of playing the tournament, we are going to play the evolution. All right, let's see who wins. I don't know, to be fair. I haven't tried it in a while. Oh, let's try it one more time. All right, so it pays off to have good memory, apparently. All right, that's it. I ran out of time. I know I used 5 minutes more than I was supposed to use. If you have any questions, I'm happy to answer them, probably first thing in the morning when I just wake up, because I will go to bed right after this talk. If you have any questions, like in 1 week, the best way to reach me is Twitter. I also started an Instagram account 1 year ago. I don't use it, to be fair, but if you want to connect, feel free. Also, next social media I have, if it still can be called social media, it's GitHub. That's also good way to reach me. Thanks for having me. I wish you a great conference. I know in Europe it's like 11 o'clock right now. In here it's 3 in the morning. So have a great day. Thank you.
Thank you, Jakub.